Okay, this is notes 1.6, algebraic manipulation. So this is for limits. So before we start this, we need to recall the following. If we have 0 divided by a number, this is 0. If we have a number divided by 0, this is undefined. Okay, but if we have 0 divided by 0, this is called an indeterminate. And let me move that because I want to put it all on one line. Indeterminate. Okay, and what an indeterminate means is it's telling you that you are not done solving the problem. There is other ways that you can manipulate the problem to get an answer. So ultimately, this is just telling you to keep going. So keep on trying to solve. So let's go ahead and look at number 1. So number 1 says direct substitution. You should always start off with direct substitution. And then if you get an indeterminate form, then you know you have to manipulate it in some way. So starting off with substitution, I'm going to plug in -1. So this is equal to -1 squared plus 2 times -1 minus 4. So this is 1 minus 2 minus 4, which is -5. Okay, notice when I am going to direct substitution, I don't have to rewrite the limit statement again. I just go and plug it in and get my answer. Okay, same with number 2. Notice that there is no function for me to plug in 2 because this is a constant function of 6. So if I had a graph, let's say this is 6, this would be my constant function, which means that as x is approaching 2, let's say this is 2, okay, from the left and the right, no matter what, is always going to approach 6. So anytime you have a constant function here, your limit is just going to be equal to that constant function. So this is equal to 6. Okay. Now let's look at number 3. So remember, our first step is to always plug in 0. So we have 4 times 0 squared minus 5 times 0 over 0. This is going to be 0 over 0, which is an indeterminate. So what you need to do instead is you need to try to factor. That would be your next thing. So anytime we're trying to manipulate, we're not solving yet, so you need to always write the limit statement. Okay, so the limit as x approaches 0, we can factor out an x. So we're left with 4x minus 5 over x. These x's cancel. And so I'm left with the limit as x approaches 0 of 4x minus 5, which I can then substitute 0 in, and I get -5. Number 4, again, always try direct substitution. So 2 times -7 squared plus 13 times -7 minus 7. All over -7 plus 7. This gives me 0 over 0, which is an indeterminate. Okay, which means I have to try to factor to see if anything cancels. So I have the limit as x approaches -7. And then I'm going to factor this by factoring it into 2x minus 1 and x plus 7. Over x plus 7, which means the x plus 7 cancels, and I'm left with the limit as x approaches -7 of 2x minus 1, which is equal to 2 times -7 minus 1, which is -15. Okay, let's look at number 5. Okay, so I'm going to now try my direct substitution. So I get -6 squared plus 4 times -6 plus 3 over -6 plus 6, When I simplify this, I get 15 over 0, which is undefined. So if I have a value that is undefined, that means I can't keep going. Okay, there's nothing else I can do. There's no way to factor this for us to cancel out the factor x plus 6. So that means my limit does not exist. Okay. Now we're going to look at something very, very, very important. So I want you to highlight, box, circle something, and then in big writing, I want you to write memorize. Very, very important. We need to memorize this. So this is special trig limits. So if we ever have the limit as x approaches 0 of our trig functions sine x and cosine x, this is the special properties and what values they are. So the limit as x approaches 0 of sine x over x is 1. And the opposite is true as well. The limit as x approaches 0 of x over sine x is also 1. For the next two dealing with cosine, these are going to be 0. So let's look at some examples. Number 6 says the limit as x approaches 0 of sine 3x x. We already know that if we plug in 0, we get sine of 0 over 0, which is 0 over 0. So we have to keep on going. So instead, we need to try to make this look like one of the properties above. So remember, the property was the limit as x approaches 0, x equals 1. Well, we don't just have sine x here, we have sine of 3x, which it means I need to multiply the top and the bottom by 3. So I have the limit as x approaches 0 of 3 sine 3x over 3x. Okay, this is the same as saying 3 limit as x approaches 0 of sine of 3x over 3x, which we already know is 1. So this one is going to go to 1. So I have 3 times 1, which is 3. That's my answer. Okay, number 7. Okay, so now I have the limit of sine of 7x and sine of 9x. Okay, so the first thing I need to do is I need to separate this into two different limits. So I have the limit as x approaches 0 of sine of 7x over 1 times 1 over sine of 9x. Okay, now that I have this, in order to get this to be the same, I'm going to multiply the top and bottom by 7x here, and the top and bottom by 9x here. Okay, so really I have the limit as x approaches 0 of 7x 9x sine 7x over 7x sine 9x times 9x. Okay, so what happens here is that this sine x with this 7x goes to 1. This 9x over sine 9x also goes to 1. So I am left with 7x over 9x, which is just 7 over 9. Okay, last one, number 8. Okay, so the limit as x approaches 0 of cosine squared x minus 1 over x times cosine x plus 1. So recall that this is the same as saying cosine x squared. Okay, so if I had this in that way, so the limit as x approaches 0 of cosine x squared minus 1 over x cosine x plus 1, I could actually factor that. So this is the limit as x approaches 0 of cosine x minus 1 times cosine x plus 1 over x times cosine x plus 1. These would cancel out, And then I would be left with the property above. So I have the limit as x approaches 0 of cosine x minus 1 over x, which is 0.